Okay, guys. Hope this works. Chapter 6 textbook review. I guess we don't have a textbook. You know what I'm talking about. Just whipping through this real quick. I will limit this to less than 15 minutes. So this first stuff should be pretty easy. You're rolling dice and you want to know what happens. I don't think there's anything crazy here at all. I'm going to skip right through this. The only thing I would say is G. There's the answer is 0 because you can't have that happen, which is totally fine. Okay, so you look at all these are how many times does it happen over 6? So like for example, D and G can happen, so the answer is 0 out of 6, which is totally fine. But if you have a question like that, make sure if the answer is 0, you write 0 because probably 0 is acceptable. These here we have the sums, so you're given something like this with the sample space here, and all you do is figure out all these different things, and then you count them, and then over 6. Right? So 6 over 36 for the first one. The sum is 4. There are 6 of those. The sum is 7. You count those. C is the sum is not 7. So the best way to do that is to figure out that the sum is 7. So you look over here. Look over over. Oh, so if you look over here somewhere, you count the 7s, and you actually got that in B that there's 6 out of 36, and 1 subtract that will give you the rest of them. Okay, as a probability. So there are 30. There are 30. Okay, we know that. Another way to do it is that there are 6 7s. There are 36 answers, so there are 36 things here. 6 of them are 7, so 30 have to be not 7. Okay, so you can do that, or what you can do here is just say that this is the probability of 7 coming up, 6 out of 36, or 1 out of 6 in lowest terms, and the probability of it not happening is 1 minus that. Okay, so, and then what we have here is E, probability of E primed, or the probability of E not happening. And then if you have different cases, so the sum in D, the sum on the face is 4 or is 7, or it is 7. What you want to make sure is you don't double count. So in this case, you can't double count because 4 and 7 are not the same thing. So you count the number of 4s. And so what the answer here, if you're confused, the answer here, why it's 1 6 and 1 12th instead of the original answers of, it's because you already asked these questions. So in A, you were asked 4. So what happened here was in A, we got this answer here of 3 over 36, which is 1 12th. And then you have 7, which was 1 6, and you added them together. What I would probably do is just go 336 plus 636 is 936 and reduce it to 1/4. So that it's just fractions of those terms to get you confused. And then we go on to 3. Same sort of thing. You just keep adding. Just be careful. But if there is overlap, for example, in F here, a 3 appears on at least one die, and the sum of the up faces is 4. The up face is just sum of the dice is 4. So here we have all the 3s. Okay, so we have there's a 3 is appearing, and then you also realize here. So if you just count these, the answer to F is going to be. Oh, I'm sorry, I messed this up. So let's look at E. 3 appears on at least one die. You count these. There's 11. Sorry, I'm looking at the wrong question. There are 11 here, so you add them up. And then in F, 3 appears on at least one die, and the sum is 4. So you look over here. Sorry, I'm over here now. 3 appears on at least one die is all the red guys. The blue guys are the sum is 4. And you just look at which ones have blue and red elements. Only this guy and this guy, 3 1 and 1 3. This is the question I meant to bring to your attention is G. If you just count these, if you go through this and count all of, so there is 1, 2, 3, 4, 5, 6, 7, 8. How many things have a red circle or a blue square around them? If you count them, there is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's 12. The answer is 12. What we've done here is we've shown you the entire way to do this. So the probability that it's A or B is the probability of A plus the probability of B, subtract the probability of B, A and B. So what that is saying is there are 11 red guys. Okay, so 11 that you said are red. Okay, so 11 things that are at least one of the guys is 3. And there are 3 instances, is that a word? Where the sum is 4. So these are these guys here. So if you add those up, 11 and 3, you get 14 cases. And there are 14 cases, but what you've done is you double counted. So if you do it this way, be careful that you get rid of the double counting. There were 2 situations where you double counted, where you have both a square and a circle here, and you subtract those. Okay, the easiest way to do it is just to count anything that has a mark on it, and there's 12 of them. Okay, so hopefully that made sense. Just don't double count. That's a long-winded version of that. Playing cards here, this is simple stuff. It's out of 52. Straightforward. The card is black and a jack. Just be careful and B, that you don't double count again. Okay, so black, jack, there are just 2, right? So if you were just to go through this and figure out how many jacks there were and how many black cards there were, and you added them up, you would overdo that. But black jacks, they're just 2 out of 52. And the last one is the card is black or a jack. Again, don't double count here. Black or a jack in C. You have all the black cards, and then you have the 2 red jacks. So what I'm saying about don't double count, don't tell me that there are 26 black cards and then there are 4 jacks on top, right? Because if you do that, what you're going to end up having is you're double counting the black jacks. So if you say there's 26 black cards, that's great. And then there are 4 jacks, that's great. So that'd be 26 plus 4 is 30 cards, but you've double counted the black jacks, so you want to subtract those. The next one here, you're going to do a nice tree diagram. A question like this is a safe question to expect on your test. So what's going on is you go until you have, in this case here, you have 4 calculators tested or 2 are defective. So you go, if D is defective, and I like to do this actually, guys, and I really recommend that you do this, is that you draw the first branch too. This way, if you count the branches, not the branches, but the splits here, it shows you that an event is happening. So here's the first event, the second event, the third event, and the fourth event. So I really would recommend that you draw that like that. So what's happening here is you go through this, and when you draw the tree, you say test, D is defective, D is good. So you go defective, good. There's no probabilities involved with this, right? But you're just drawing the number of branches here. So D and G. Second, you go D and G, D and G. And what you do is you would stop here. You keep going until you have 2 Ds. So that one, you're done. So you're done here. Then you would split this guy, D and G, and now you have 2 Ds here. If you follow this, it's D, G, D. So that guy's done. And I'll just stick with the top here. And then you go here, and then you're done here no matter what, because you're done here because you have 2 Ds. Done here because you have 4 calculators. On the bottom, same sort of thing. You stop this guy here because you have 2 Ds. This guy would have stopped, but you're going to stop them all here anyway. Okay, so you would look at this whole thing. Then you follow the paths, and to figure out what happened. Oh, gosh, what happened now? Use my. This is high. Did I just scream? I did. Oh, Lord. I'm not deleting this. Okay, you're going to have to deal with this. The magic is gone here. What's going on here? What's going on? Let me write in purple. I want to write in purple. Too much to ask for. Okay, so what happens is this guy and this guy go to DD. This guy here goes here. Okay. Yeah. Just wait. This is a cheap version of Smart. I don't have my key ran out, so I don't have half the stuff here. I don't have. Where's my eraser? Great. Stupid thing's making a fool of me. Eraser, found it. Okay. Let's follow this now from scratch. Okay. So that too bad. I just ignore the last minute. Okay. And hey, how's it going? Good. D and D is this guy. We follow this guy all the way through. DGD is going to be, yeah. So there's a mistake here. That's what's driving nuts. This guy here should be a D at the end. Okay, because you go DGD. This one here is going to be DGGGD. Okay, and whatever. Keep going through. Let me just see if there's any more mistakes. They shouldn't. Everything should either have 4 letters and or have 2 Ds in it. Okay, so they stop at 2 Ds. Some of them have both, and those guys would have stopped. But anyway, that's it. Okay, so there you go. and calculate the probability of each of these happening. Okay, so when you look at these things, you look at them, and the event E consists of all outcomes where exactly one defective calculator is tested. So go through here and see how many of these have 1D in them, and there should be 4 of them with 1D in them. Okay, so there's this one, there's this one. I don't know, there's 4. Okay, I'm running out of time. And this one here is the event that there's 2 acceptable calculators, so you look for 2 Gs. Okay, and there's 3 of them. Next, I gotta whip through this stuff. 6 balls are the probability of this sort of thing happening here. Exactly 4 balls. So you're pulling 6 out, and you want 4 of the red ones. So here there are 8C4 red. So you choose 4 red, and then that means you have to choose 2 non-red. Okay. And there are 8 red, and the 9 are yellow. And what you're doing on the bottom is going to be the same every time. You have 17, 6, because that's what you're doing. You're choosing 6 of the 17 balls. And then this one here, at least 4 balls. You have to figure out 4 red balls, 5 red balls, 6 red balls, and you stop there because you maxed out at 6 balls, because that's all there is being tested. This one here, you draw a tree, 60% and 40%, so 60% chance of your car starting, 90% chance of your parents' car starting. You draw a tree, and then you follow the cases, you follow it through. And then what you're going to do is, when you want an answer here, what's the probability of something happening, you're going to multiply. So for example, when I look at B, both cars will start, that's SS. So that's going to be here 0.6 times 0.9, and that's how you get this. You add when you're looking at separate cases. So for example, you're looking at in C, exactly 1 car starts. So that'll be this guy and this guy, because this one has 1 case that's start, not start, that's not start and start. And you'll find out what that is and find out what that is and add them together. Okay, so I'm whipping through this because I'm short on time. This is my little mistake there. The sum is 12. These are easy. Okay, so except for we're talking about odds. I'm sorry, they're not easy because we're talking about odds. So remember, for odds, you have at the end, what you're going to have is NE2 and E not happening, or prime. So how many times does this happen? How many times does that happen? And it happens 1 time, and there are 35 not of those. So that's that. Now we did them as fractions just to reduce. So these are how you do those. Odds in favor check. You notice we have a bunch of these. The one thing that you notice is these 2 numbers here will add up to 36, because this is 36. So whatever's here, this is always 36, subtract that. Okay, so you look for an event, it happens twice, which means it doesn't happen 36 subtract to 34 times. So that's how you get the 2 and the 34. Reduce lowest terms, and then state as a fraction. Okay. Odds in favor, odds against would be the opposite of that. So you would get, all you do is take these numbers and swap them like that, 17 to 1. Okay, I'm 2 minutes left. Heads and tail question, just follow them through, and then figure that out after. Okay, just follow each of those through, and then you have how many outcomes, 8 in total, and then count how many are success depending on the question. These here are very similar to the last question about taking balls out. You take 2 out of 9. You're doing that over again, and then you just figure out what you want to happen on the top. So on the top, what is the probability that 2 will be red? In this example here, you're choosing the 2 red ones, and then you're choosing 7. Of the other 7, you're choosing none of those. Okay, so very similar question to the one I just did. Minute and a half left. You have 2 boxes. The first box contains 3 red balls. Same sort of thing here, except sorry, this is 2 different boxes. I'm sorry, this is not the same sort of thing. So you figure out what happened, the probability of success in the first one. So 3 out of 7 chance of success in the first one, 6 out of 11 on the second. You could draw a tree for this too. I wouldn't bother, and you just multiply the 2 together. This one here is a word question, not that difficult. Okay, so again, you have 4 cards. You're selected at random from 8 cards. 3 of the cards are this, marked like that. What is the probability that exactly one of the cards will win $100? 3 of the 8 cards are marked with this. So you look here and you say, I want exactly 1, which means I draw 1 of the 3, and then I draw 3 of the 3 of the 5 non-written ones. Okay, and this one here is yours. It was a probability that no card wins $100. You could also add on top here. You could, if you wanted to, you could also have this. C, choose that, and don't forget this is the same as this. I tend to write that. This is the same as that. Okay, and I'm almost out of time, so hopefully that was enough for you. If you have any more questions about any of the other ones, come and see me. This one's difficult. I'll tell you one question that I'm not a fan of, or will I?